Hello everyone, I am Ruchi Rangari from DAVV IRPS and you are watching my tutorial on Dijkstra Algorithm.
What is the single source shortest path problem? The problem of finding shortest path from a source vertex V to all other vertices in the graph is the single source shortest path problem. The Dijkstra algorithm is the solution for this problem. The Dijkstra algorithm is used to find the shortest path in the given graph. The Dijkstra algorithm is a solution to the single source shortest path problem in a graph theory. We, this algorithm works on both directed and undirected graph, and in the graph all edges must have non-negative weight. We will use greedy approach to solve this problem. Input of the algorithm is the weighted graph G, which has set of edges and set of vertices, and source vertex V, which belongs to set of vertices, such that all edge weights are non-negative. Output of the algorithm is the length of shortest path from a given source vertex V belongs to V to all other vertices. Now the algorithm. In the algorithm, I have used the function shortest path, which have four parameters v, cost, dist and n. V represent the number of vertices, cost represent the adjacent vertices from the current node, and dist represent the distance between two nodes, and n represent the number of nodes. In the function, first for loop will execute for the number of vertices, that is for I from 1 to n. S of I is set to false, and distance of I is equals to cost of v comma I. S of v is set to true because v is present in S. S of v, distance of v is set to 0. Now the second for loop is for num is equals to 2 to n minus 1, and S of u is set to true, that is because u is present in S. Now the third for loop is for each w adjacent to u with S of w equals to false. If distance of w is greater than distance of u plus distance plus cost u and w, then distance of w is equals to distance u plus cost u and w. Now let's look at the example. In the given graph, we have 5 nodes a, b, c, d, e. We want to find out the shortest path from a to e. So we'll start by marking out a with the source vertex, and we will label a with the weight 0. Now we examine each of the node adjacent to A, that is B and C. A to B distance is 10 and A to C distance is 3. So we label B with the weight 10 and we label C with the weight 3. Now we select the path A to C because it is the shortest distance. Now starting with C, we examine each node adjacent to C, that is B, D and E. C to E distance is 2, C to D distance is 8 and C to B distance is 4. So we relabel B with the weight 7 and we label E with the weight 5 and D with the weight 11. Now we select the path C to E because it is the shortest distance. Now we examine D, which is adjacent to E. E to D distance is 14, so we will not relabel D with the weight 14. Now back traversing the path E to C, so we will find out then that C to B distance is 7, so we select the path C to B. Now we examine each node adjacent to B, that is B to C and B to D. B to C weight is 8, so we will not relabel C with the weight 8, and B to D weight is 2, so we will relabel D with the weight 11 with the weight 9, and by this method you can find out the shortest path in the given graph. Now the time complexity of Dijkstra algorithm. Steps of the algorithm: steps per execution, frequency, total step. Algorithm function shortest path, which have 4 parameters v, cost, dist and n, and the steps per execution is 0, frequency is 0 and total step is 0. For loop I equals to 1 to n is steps per execution is 1, frequency is n plus 1 and total step is n plus 1. S of y is equals to set to false, that steps per execution is 1, frequency is 1 and total step is 1. Distance of I is equals to cost of v comma I, steps per execution is 1, frequency is 1 and total step is also 1. S of v is equals to true, steps per execution is 1, frequency is 1 and total step is 1. Distance of v is equals to 0, that is steps per execution is 1, frequency is 1 and total step is 1. For num equals to 2 to n minus 1, so steps per execution is 1, frequency n minus 2, and total step is n minus 2. S of u is set to true, steps per execution is 1, frequency is 1, and total step is also 1. Third for loop for each w adjacent to u with s of w is equals to false, steps per execution is 1, frequency is n plus 1, and total step is n plus 1. Condition: if distance of w is greater than distance of u plus cos u comma w, steps per execution is 1, frequency is 1, and total step is also 1. Distance of w is equals to distance of u plus cos u comma w, steps per execution is 1, frequency is 1, and total step is also 1. And the total time complexity of Dijkstra algorithm is big O n square.